Hello and welcome to Computer Graphics session of Spring 2017. In Lesson 2 we will continue with our Hello World for Computer Graphics. Before going on, make sure you have Chrome or Firefox browser, a programming editor like Sublime, the triangles.html file from Lesson 1. The WebGL2 reference card will be handy. And lastly, you need a lot of patience and determination to see this through. As of January, Firefox, Chrome and Opera has implemented WebGL2. Shaders are programs that run on the GPU. Vertex shader comes first in pipeline and are executed for each vertex. Fragment shader are executed after Rateries RTO. Both shaders are written in GLSL. For WebGL2 the version used is 3.0. To use GLSL version, this preprocessor directive must appear in the first line. GLSL is a C-like language with built-in data types for computer graphics. The main function returns void and cannot take inputs. However, there are some built-in inputs and output. For example, in Vertex shader, programmer must give a vec4 value to GL_position variable. GLSL defines some qualifiers for variables. In version 3, attribute is changed to in and varying is changed to out. We will see them in action soon. Let's start by first changing the context to WebGL2. Simply add 2 after WebGL. There are other ways to add GLSL code in your WebGL program. I find this one most practical. We add AX shader script and give it an ID. Do the same for fragment shader but change the subtype and ID. The version preprocessor directive must be in first line. We have our main function as told before. We need to create an input variable to tell the vertex position. The value will come from application. To keep things simple, we will just directly assign the received value to GL_position built-in variable. Remember, it is your responsibility to always assign a valid vec4 value to GL_position in Vertex shader. For some reason, fragment shader expects that we tell it the accuracy at which we will work. This line does that. Fragment shader must have one out variable that determines the color to display. We will call it fragment color or frag_CLR for short. Our shader definition will end with main function. For now we are just painting everything blue. This is going to take long and might get complicated. But you need to know it once. Next time it can be placed in a function and used without the details. The comments will make the code long and difficult to read, but are there for academic purpose and your ease. Let's get the shader code from the shader scripts using the ID we assigned earlier. This will create objects for making shader programs. Fill in the source code in our shader program objects. Time to compile. The compiled shaders must belong to one linked program. The program object will help us do that. Need to attach shaders to the program link and tell GPU to use this program. We need to define the triangle to show. Keeping it simple, it will be a right angle triangle. The data sent to GPU must have a type. Unlike JavaScript where there is no type, the data is therefore stored in float32 array. The first point or vertex is the origin, followed by point on the straight up on the y-axis, and last point is 0.8 units to the right of the center. Data on GPU is stored in buffers. Let's create one. We must tell WebGL which buffer we will use from this point onwards, and how, by binding it. Telling where the data of the buffer is. All details can be found in the reference card. Since a vertex shader can have multiple variables, we need to tell which variable will use data from this buffer. This gets the location of variable VPOS in vertex shader. The current binded buffer will get pointed to this variable in vertex shader. First argument is the variable location, second argument specifies how many elements of buffer contribute to the variable. Third is the data type. The size is necessary, because an attribute can be of vec2 3 or consisting of multiple elements from the buffer. Normalized data span between 0 and 1. The reference guide tells us that draw arrays function need 3 arguments. First, the primitive we want to draw. In our case, it is triangles. Second, whether we want WebGL to start drawing from first point or somewhere in between. And last, how many vertices we want WebGL to draw. Refresh, to see your first triangle. WebGL cannot draw shapes other than triangles and lines. To make a square, make 2 triangles. We need to change number of vertices to draw to 6. Refresh the page to see the square.